Often when people think about solving a quadratic equation, one of the first things that comes to their mind is the quadratic formula here. It's usually one of the first things people learn when they first learn about quadratic equations at whatever grade that happens to be introduced. So I'm going to take a little bit of time actually just by deriving this formula. And the reason that the quadratic equation looks the way it does, the reason that it gives a solution is because it is what you get, it is the expression you get when you try to solve this general quadratic equation that we have here in example 79 by completing the square. So try not to be too fazed by the fact that we don't have actual numbers here as our coefficients, but a, b, and c are some real numbers. And we're going to start off just like we usually do by throwing the constant on the other side. So let's subtract c. This gives us ax squared plus bx equals negative c. And again, we want to complete the square in a plain old x squared, 1x squared, not 2x squared or minus 3x squared or even ax squared. So we're going to divide through by this coefficient on x squared. And this gives us x squared plus b over a times x. I'm going to leave a little bit of space. Equals minus c over a. Now we're ready to complete the square. And so we know we're going to take this coefficient on x, which is b over a, cut it in half, and then square it. So when you cut a fraction in half, it's the same as doubling its denominator. So there's b over 2a. That's half of b over a. Then we're going to square it and add that to the right side as well. Now we've chosen to add b over 2a all squared to both sides because it is what gives us a perfect square on the left. So just as before, that means we're going to start off with the x. This is a positive plus b over 2a. So we have the square of x plus b over 2a is equal to, and now I'm going to have a little bit of algebra to do to add these fractions. So I've got minus c over a plus, and when you square b over 2a, you get b squared over 4a squared. Or you get to square the top and the bottom of that fraction. Now we want to do a little bit more work here on the right side before we're ready to take a square root. And in particular, let's get a common denominator. So to get a common denominator, this minus c over a, this first fraction needs to pick up a factor of 4 and a factor of a. And so we can do that as long as we also multiply by 4a on the top. And now we have our common denominator of 4a squared. And on top we have a minus 4ac plus b squared. And I'm actually going to just take a moment and rewrite that fraction. Rewrite that numerator as b squared minus 4ac. So now we have this perfect square on the left side is equal to that fraction, and we're ready now to take the square root on either side. What we need to do now is a little bit of simplifying. On the left side, of course, just as all the other times, we're taking the square root of a perfect square, and so that means we just have x plus b over 2a. On the right side, we have to consider both positive and negative roots. We have this fraction inside the radical, and we can split up a radical over division. Which is fairly convenient for us because the square root of 4a squared is equal to 2a. And so now we can actually go a little bit further. And write x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. And now we're almost done. The only thing left to do to get x by itself is to subtract b over 2a from either side. So we have a minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. And we have a common denominator on the right side, right? Both of those fractions have a denominator of 2a, which means we can write it as a single fraction. And the numerator is a negative b plus or minus the square root of b squared minus 4ac. So there's our quadratic formula. And we're now sort of feel justified in using that quadratic formula. We understand where it comes from, and we can actually derive it and see why this formula is true, and we'll give the solutions to a quadratic equation.